Welcome, everyone. My name is Jordi Ricard, and it's a pleasure to introduce the third session of our Journey to the Cloud series. Today, we will talk about Amazon Web Services after the initial sessions about Microsoft Azure Synapse and Google Cloud Platform. You can find those sessions online in our website and social networks, so you can reply them if you didn't have the chance to attend. With that, it's my pleasure to hand over the session to Oscar Martinez, head of our Big Data and Cloud practice. Oscar, can you share the highlights of this series of webinars we are preparing?
Thanks, Jordi. Yes, today we are going to be talking about Amazon on the third session of the series. On the first session, Manuel gave a very interesting deep dive on Azure Synapse. On the second session that we did in July, Victor gave a good overview of a interesting solution that we have implemented for one of our customers in ClearPeaks. And today, Esteban, in a couple of minutes, will explain you another implementation that we have done for one of our other customers. In this implementation, as Esteban will say, we have, I would say, enriched the out-of-box capabilities of Amazon with our expertise and our best practices on implementing data platforms. I think it's very interesting how we have handled the CI/CD on this project. But Esteban will tell you more about that in just a few seconds. This is the third session, as we already repeated a few times, but there are more sessions that we are cooking as of now, and the exact order we still don't know. They are going to happen in the fall, in the coming weeks or months, and we're going to be featuring sessions on Snowflake, Dremio, and Cloudera, and we are also officially confirming another session on Oracle Cloud, because we do have a lot of business and a lot of activities with Oracle Cloud. And it's also very interesting, the stuff that you can do on this cloud. Okay, so now, without me taking more time, I will leave you on the very good hands of Esteban. So Esteban, all yours.
Okay, thanks, Oscar. So let's first check the case, on which we build this platform on Amazon. So one of our main clients approaches us because they were having issues with their business KPIs. So as it happens normally, the business KPIs were not provided as business user design. So they're having several issues, such as a lack of historic data sets, or KPIs could not be calculated on the desired frequency. Also, they were experiencing several, say, technical issues, such as limitation in terms of resources, because they were using still on-premise systems. And also important to keep in mind that they have a big BI team, so it's a team of 10 that is working on the platform and doing BI and data engineering tasks. So when this customer approached us, the solution we designed to overcome these limitations, and the benefits they got once the platform has been implemented and delivered, is that so we build this platform, this data platform in the cloud. Okay, as you will see, we mostly use platform as a services, okay, to reduce the operational overhead, the IT overhead, let's say. So you will see throughout the presentation that no virtual machines have been used at all. Also, you will see how all the infrastructure has been defined with Terraform and deployed following the CI/CD practice. Well, both infrastructure plus the business logics. As it usually happens, there are some existing BI pipelines already in place, that have to be reused because they host a lot of logic. So these BI pipelines, some of them has been lift and shift, others have required a bit more work and have needed some refactoring. Okay. On the way, this client wanted to scale up on our BI methodology, so we have had several knowledge transfer sessions to them, explain how we work with our methodology. The goal of this methodology is to better take business requirements and deliver appropriate business KPIs to the users. Okay, so to start, the first thing that comes to our mind when we have to design a platform on Amazon is, okay, which service do I use? As you know, Amazon has a plethora of services, kind of bricks that you have to put together, and there are a lot of them. And it seems that each one of them is the best one, and it's sometimes, or most of the times, it's not easy to identify which one fits best in our use case. Okay, so in here you can see the schema of a big data platform along with its layers and the Amazon services that implement those. So this is kind of the final picture already of what has been built. So let me introduce it a bit. So on the left, you can see the data sources that the client have. You can see two of them, two origins. And you can see that one of them, we have highlighted this restricted read access. That later we'll come back to this restricted read access, but just keep that in mind. Then the ingestion layer, this collect layer, was implemented basically with glue jobs. Okay, these glue jobs store the raw data without transforming it into the data lake. Amazon doesn't have a data lake service as such. The data lake is built or is made of several or other services. As you can see, S3, LakeFormation, and Glue as well. So once you have your raw data in the data lake, the next step is usually to start transforming, messaging this data to calculate the KPIs. So the transformation layer, which is implemented by glue jobs again, is the one in charge of implementing this business logic. The result of these transformations are stored in a data warehouse, where we have the fact, dimension, aggregated tables. This was an RDS Aurora database. Who was in charge of orchestrating that? One approach might be to make this platform event-based, but we prefer to follow more or having an orchestrator in charge of triggering and orchestrating the rest of the services. For that, Airflow was the chosen one. As you can see, NWIA, that means basically is the managed service for Airflow that Amazon released recently. Okay, when it comes to consume this data, we use QuickSight, which is the visualization tool. And for users that wanted to do some data analysis, there's the Athena, okay, this service let us interactively query the raw data sitting in the data lake. Okay, back to this restricted read access that I mentioned. What happened was that the client had this database to which basically we cannot access the live system to read data. Okay, so the only way to retrieve data from it was to start from a backup, restore the backup into transient RDS database, then a glue job will run and ingest this data from the restored database into data lake, and once it is done, the database gets deleted. Okay, all of this process is implemented by Airflow. So as you will see here, there are some transient resources created on the way by Airflow. We'll again come back to this process later. And still on the overview, in here is the final picture on how the CI/CD practice along with the Amazon environments are together. So we can see that we'll get later again into the same picture. But basically, as an introduction, you see that we had the Amazon environments, a testing one, staging, and the production one. We had several GitHub repos where the code got stored, and Jenkins was the automation tool. Okay, now that you have, say, an initial picture of the platform, we are going to get into the detail of the Amazon service that have been in use and explain a bit interesting things of them. So the first service is the Airflow one, the managed Airflow service. As I mentioned, Airflow is the workflow orchestrator. Airflow defines DAGs and tasks, okay, that basically are Python scripts. And for the ones that already use Airflow, and you had to build a cluster yourself, okay, you know that there are the scheduler, the workers, and the web server. When you deploy the managed Airflow in Amazon, things becomes much simpler because it's only kind of one service, one instance that you have to create. So you get, you still can decide the scheduler, the number of workers you want, but you don't have to deal anymore with integrating like the virtual machines to create this Airflow cluster. So things becomes much easier. Here in the building blocks, you can see what you need to create to work with Airflow. So in our case, Terraform created the Airflow instance. That was done by the cloud engineer. And then the Airflow DAGs and the related libraries used. These are stored in S3. Okay. And one important thing to keep in mind in here is that Amazon Airflow, okay, the managed Airflow cannot be turned off. So once you spin it up, you cannot turn it off. That has a high impact when you especially if you want to do some POC, that you want to just create one single DAG to run once per day. It will cost a bit more than expected because you cannot turn off Airflow when you want. So also we have used Airflow as a pure orchestrator, and we have avoided using it to process or transform data, even if it's possible, because at the end of the day you can process some data in Python, but we intended not to do that. And then as a thumb rule, Airflow was in charge of triggering glue jobs. But as explained before, also on Airflow we create transient resources, transient Amazon resources, using the Amazon SDK. Okay, the Glue service. Okay, Glue is a fully managed service, is a platform as a service. Again, we have used mainly two flavors of it: the Apache Spark one that provides Apache Spark clusters, and the Python shell ones. And in addition, the Glue service also provides the data catalog, which is the Hive meta store for the data store in the data lake. The building blocks of Glue might look similar to the ones of Airflow, So you have Terraform that creates the Glue job, and then you have the Glue job scripts and the libraries that are stored in S3 and are referenced by these Glue jobs. The difference in here is that each Glue job is defined in Terraform. So our platform has around 40 Glue jobs. So each Glue job is defined in Terraform. That means that every time you need to create a new Glue job, the cloud engineer needs to be involved to define it in Terraform as well. So regarding our implementation, we have used a couple of Glue methods, the ones described in here, that avoid us or running in high frequency the Glue crawlers. Okay, so that simplified the Airflow DAG. So when the Airflow DAG triggered the Glue job, we got the data catalog database and tables updated without running the crawlers. And as I mentioned, we use two types of Glue jobs, the Spark and Python ones. As a thumb rule, we use the Python shell to move data and the Spark ones to transform the data. Okay, and the LakeFormation. Okay, here things might get a bit more complicated. So the LakeFormation service is quite a recent one that was released 2-3 years ago. Okay, it has several functions, and it overlaps a bit with Glue. Okay, or overtakes, or is going to overtake Glue in somehow. So the main usage that LakeFormation has had for us is to control the data access. So control the access to the data catalog tables. Okay, LakeFormation intends to simplify this data access to the data catalog information versus Glue. Okay, in Glue, you had to deal with AAM policies to grant access. LakeFormation simplifies this setup using another approach, and you can control the access down to the row and cell level. How LakeFormation does it? So it proposes the use of these LF tags, LakeFormation tags. Okay? How that works? We can see that on this picture designed by Amazon that you can see here on the right. No? So basically how it works is you define tags, no? Such as departments, and you can assign like the sales key to one database, the orders to another one, customers to another database, and then you assign these tags to the IAM principals that need access to those. So it becomes much simpler to know, to grant who has access to what and to revoke this access. Another capability of LakeFormation that has been released recently and is worth mentioning is these governed tables that will accept ACID transactions. Okay, we haven't used these governed tables in our project, but is worth mentioning it. And then regarding the project implementation, some feedback on it is the project or the initial setup of the LakeFormation is quite complex, especially because it overlaps a bit with the Glue data log configuration. Okay, so there's a few things that needs to be configured, like the LakeFormation administrator. You have to define who is going to have access to assign these tags. Okay, you have to register some S3 locations. And the initial setup is a bit complex, also because you have to Terraform it, and then you check what's happening in the console, so it's a bit tricky at the beginning. Nevertheless, once it is in place, test it, and you are happy and with it, then the daily operation and the scalability of it becomes much simpler. Okay, the next service is Athena. Okay, the service that let us query raw data from the data lake. So Athena is this interactive query service that basically you can run queries, which uses a combination of Preston and CSQL. In addition to run queries, you can also add tables, so you can fill up the data lake as well. Okay, what's important in Athena is you pay per the data scale. Okay, so depending on how you partition the data, how the queries are prepared, you're going to pay more or less. So what revolves around Athena is controlling this, how much data is going to be scanned. So for that, Athena define work groups, okay, that you later kind of assign them to IAM principals. And thanks to these work groups, you can define the amount of data scan per period, and also you can limit the amount of data scan per query. We implemented these limitations, but still we had to rely on Amazon budget to have a better control on the cost. Okay, because the thin out of the box limitations were not enough in our case. Okay, QuickSight. QuickSight is the visualization tool. Okay, it's the equivalent of Google Data Studio, for instance, and is a managed service. So there's no virtual machines again to manage underneath. For the ones that have already used QuickSight, you will see that QuickSight is not perfectly integrated with the Amazon console. Okay, and it has a dedicated user management interface. Okay, so there's some user management has to be done within QuickSight. It has two types of data sets: the spies, the one that catch some data, and the direct query that basically, while you browse through the dashboards, just query the data warehouse. One of the drawbacks of the service is that it is not possible to export the datasets and dashboard via Amazon, the SDKs or Terraform. Okay, so you can only create these dashboards via the console. So this drawback, the impact it has is that it's not easy to integrate QuickSight in your CI/CD practice. And if you recall the picture of our full CI/CD approach, Airflow didn't have the repo included in it. So as an alternative, because of this lack of integration, Amazon proposes another approach which is a kind of an object migration approach. So Amazon has developed a set of functions that you can run in SageMaker notebooks, for instance, where you can basically move objects from one environment to another environment. So that's how we have implemented it. We develop in our testing environment, and then we run some scripts that basically move the objects into another environment. In addition to that, we have developed a function in Airflow that what it does is it refreshes a spice data sets once the data is available in the data warehouse. No? So we ensure that the data pipelines are smooth and the data gets refreshed as soon as it is available in the data warehouse. That's something easy to develop and is a big gain from business perspective. Okay, so this is like we get into this infrastructure creation. Okay, on the left we can see the evolution of how you can create infrastructure in Amazon. No? And at the beginning you could only use the Amazon console. Later on the CLI was introduced. Then the software development kits were also ready. Okay, and finally CloudFormation, Terraform tools were in place. And let's say this is the ones to use and the ones that really simplify the creation and the maintenance of this infrastructure. Okay, so as long as you should always rely on infrastructure as code. And if for some reason it's not possible, then you move back to the Amazon SDKs. On the right, you can see a brief intro on how Terraform works. You know? So basically, you write the configuration files, the scripts, that normally you test that in local. No? You run a plan, and Terraform basically says, okay, I'm going to create a database, I'm going to change the security group, and I'm going to destroy this other resource. Okay. Once you are happy with the new version of the infrastructure, then you apply it. Okay. In our case, the system in charge of applying it was Jenkins. No? So once the Jenkins pipeline gets triggered, he's the one applying the Terraform configuration. Then the Terraform state file, which is the one that holds the state of the infrastructure node that's kept in an Artifactory. Okay, and here let's see how the infrastructure was created in our project. Okay, so you can talk about Terraform, but when you start building a project, you usually have to do some spikes, test some integration, filters, and so on. So for that, usually you go via the console, no? Because you can do things faster. Sometimes it's more intuitive. So usually on the testing environment, we start creating things in the console. Nevertheless, once we're happy on this, we start terraforming that, okay, and applying the Terraform plans, applying the Terraform code into the testing environment. So which are the takeaways, of following this approach? One is the risk of forgetting minor changes done on the Amazon console. So sometimes it happens that part of the infra is created via Terraform, and sometimes you do small changes because you are testing something in the console, and then you forget about that. And once you move to the staging, things break, and then you realize something was not included in the Terraform. Another difficulty is that sometimes things might look a bit different between the Amazon console and Terraform. Like the creation of a database might be different. A bit at the end of the day, it's going to be the same database, but it might be different. Also, take into account that sometimes the person doing a spike is one person, and the person terraforming it might be a different person. So transforming from what was done in the console to the Terraform code is not that easy as it might look like. Another difficulty is how to name resources. So, well, the approach is to basically include a suffix that indicates the environment on most of the resources. But it happens that because some resources must be unique, such as the S3 packets. Okay, S3 buckets cannot exist two buckets with the exact same name, no? And that's the case, or the suggestion is to use suffix in most of the resources. Nevertheless, there are specific resources that we reuse the same name across the three environments, such as the glue job script file names. Now, this is the script that is being called by the glue jobs. And as this script, this glue job script, this lives in the GitHub as a file. No? So you cannot have a different script name per environment. You have to keep the same. So, well, that's something to always keep in mind while you prepare your infrastructure. And then, as already explained throughout the session, we use the Boto3 library, the software development kit for Python, to create these transient resources, to read data from this restricted read database. So sometimes we had in the infrastructure stuff created via Terraform and other things created by Airflow, not using Terraform. Let's say there's no impact on creating resources in two different ways. Okay, Terraform is only aware of the resources that he has created. Okay, so things not created by Terraform can be also created. The only thing to keep in mind is to ensure you keep the infrastructure consistent. You don't forget things without being deleted and so on. Okay, let's get into the continuous integration, continuous delivery. So here on the left, you can see the code repository strategy, which main repos we used. So one dedicated to host all the Terraform code, which was the infrastructure repository. Another one where all the Airflow logic was sitting, so the DAGs along with its libraries. The data collection repository, so the ingestion layer, glue jobs. Okay, and then we had several repos for the transformation layers. One per department. You can see it like that. And then regarding the CI/CD, how it was implemented. So continuous integration. Okay, so we do frequent merges to the develop branch, and some automatic test was done to check the format and to run a Terraform plan. Okay, and then once the future branch got merged into develop, that triggered an automatic deployment to the testing environment. So we could check how a new development was doing. Regarding the deployment, so on every release cycle, which happened every 2 weeks, once the code got merged into the main branch, that triggered an automatic deployment to the staging environment. Okay. Then if the release is valid and the tests were successful, the deployment to the production environment was done manually. Okay. As already explained, Jenkins was the automation service, and we had several pipelines created, so several per environment, and also one per repo. Okay, and here again we can see the same picture with all the pieces together. So, well, basically it summarizes what I've been explaining. Okay, and let's get into the demo. So now we are going to see how we are going to put on our data engineer's hat, and we're going to see how a data engineer can prepare glue job scripts easily. So Amazon provided 2 ways or 2 environments to develop glue jobs. Well, or a third one, which would be develop on Amazon console. Okay, but that's fine if you want to do a quick test, but that's not something a data engineer wants to spend his day on. So the legacy approach was this glue development endpoint. That was basically a standalone cluster that Amazon deployed that had the same, that was a Apache Spark cluster, and you had to connect to it. So basically this cluster was created by a cloud engineer via the console or Amazon CLI. And the provisioning time of it was around 15 minutes. Okay. On the other hand, the new service, the new version, is the Glue Interactive Session, which is a service that you can spin up using Jupyter Magic Commons. So you still need Amazon credentials for sure, but it's easily to be spin up by a data engineer, and the provisioning time is much faster. Okay. What are the advantages of the Glue Interactive Sessions? So developers can create their Glue sessions on demand. Here, keep in mind that this, like Glue development endpoint and Glue Interactive Sessions, are single user, no? So only one data engineer can be developing on it. So if you have several of them, it becomes a little tricky to manage how many development environments you need, no? Because each person will need its own. So with Glue Interactive Session, every person can create a session whenever he needs. Then it gives us more agility to include or modify the imported libraries, because these libraries, as you will see now, are imported when you create let's say the cluster. And also the Glue Interactive Session is the one supporting Glue 2.0. So most probably at some point the Glue development endpoint is going to be deprecated. So let's get into the demo where we'll see how the Glue Interactive Session works. Okay. So that's my laptop where I have the Jupyter Notebook server installed. You can see that it's running locally. So in here, what we do is we'll spin up this Glue session, okay, that will kind of simulate a Glue job, okay, and we'll create this resource in Amazon from using Jupyter Commons, okay, without running or without accessing the Glue console or running Glue Amazon CLI. Okay, so my Amazon credentials, the secret and the access key are already in my laptop as well. So to create the Glue Interactive Session, we have to define several parameters. There are a few others that can be configured, but we have reduced to these ones. So basically, the IAM role that the Glue Interactive Session is going to take, and we'll let it interact with other services, your profile, the region, session ID, that's good to know, like who has created that. Idle timeout, that's in minutes. I've put it like 5 minutes. That's worth establishing it because by default it's 2 days. And you can also define additional Python modules that you want to import into the Glue job. That's also possible in Glue, so you have to replicate that in the Glue Interactive Session. The number of workers and the worker type can also be defined. So first thing is to just we run this cell. Okay, we see here the outcome of it. Well, we see the parameters, additional Python module. Now we see that this instantiation is being created. Okay, it takes around 1 minute. And then what we'll see in the second cell, we'll see the Python modules available. Okay, now we'll check how this XML2D library has been correctly imported. And finally, we are going to execute this snippet of code that basically reads a database that we use for running benchmarking tests. And one of the tables of this database that is stored in our data catalog. Okay, and then we are going to prime the data frame of it. Okay, so the session is ready. Okay, so this has been created. This is a prime that tells us that it's ready to be developed. So let's first run this one. Okay, so in here we can see the module download install plus the version of it. And then if we execute this cell, we can check here this database, tpcdb. and the tables. Okay, we are going to read the region table. So we execute this one. Should see 5 rows of this data frame. Okay, here they are. Okay, so the outcome of it, of this short demo is basically to see how easily it would be for a data engineer developer to spin up a cluster, okay, well, a cluster interactive session, to make it available, to shut it down, okay. If he finishes, he has just execute another magic command to shut it down, and basically how easy it would be to change the libraries and basically to develop, which is the goal of this tool. Okay, so back to the presentation, to the wrap up and conclusions. So first of all, we have seen how Amazon is a valid option to build a big data platform. It provides all the layers, ingestion, storing, data lake, transforming, and also to consume this data. They can be easily integrated, but still, it's important to identify which services suit best for you, because the ones we have explained have suited our use case, but maybe yours is a bit different. So it's always good to review that. Also mention the CI/CD practice and the use of infrastructure as code tools. The faster approach to deliver an initial release would be to create everything from the console. But thinking on the mid and long term, and especially if the teams that are going to work on that are mid and large teams, it will take a bit longer to build and deploy the platform following CI/CD practice and deploying it with Terraform, but it's really worth doing it. Okay. And finally, think of how that engineers are going to develop on the platform. We have seen how to develop on Glue, but also keep in mind another element is Airflow. Okay, so there's another approach on how to provide an Airflow development environment to developers. So that's something not included in this session, but something to keep in mind. And we will probably read a blog post of it as well. Okay, so that's all from my side. Well, just mentioning that we have blog articles in ClearPeaks. Okay, we have written several of them regarding Amazon technologies. Coming soon there's a blog that is going to explain more in detail how the Glue interactive session works. So I recommend to check it out.
So thanks everyone for watching. Thanks especially to the LinkedIn the people that has been LinkedIn watching and supporting us. Have a great rest of the day. Bye bye.